Hello. In this talk, we will see how we usually deploy Kong Enterprise and share all the tips and scars we've earned doing so. My name is Philip Scorsolini. I work as a DevOps and product engineer at SIGHUP. And
my name is Samuele Chiocca. I work as a Kubernetes solution engineer at SIGHUP. My daily work is about delivering Kubernetes cluster and Kong cluster.
At SIGHUP, we have built our own Kubernetes distribution, Fury. Our main focus is helping companies adopting cloud-native technologies and transitioning to Kubernetes. So let's see the big picture. What do we need to deploy Kong Enterprise in production? A little disclaimer. In this talk, we will mostly focus on shortcomings of version 1.x of Kong Enterprise. Some of them have already been addressed in the latest releases, but we'll see them and point out which are which. So we'll definitely need one or more control plane nodes, obviously. Kong assumes only one node at a time is interacting with a database, otherwise inconsistencies might happen. A single node with a reduced mean time to repair is totally acceptable, given that the control plane is not on the data path, and the business critical functionalities are not affected in case of its failure. As a DB, we usually go with Cassandra. We'll discuss the choice more in details in the next slides. If we need some plugins requiring Redis, we usually set up a 3 or more node cluster of Redis with Sentinel. Then we'll need a pair of load balancer in front of everything. And to monitor it, we usually deploy Prometheus and Grafana. Sizing will depend on the expected load, obviously. As I was saying, version 2.x changed a few things. The biggest change is that now Kong Enterprise can be deployed in hybrid mode, which allows to better separate control plane and data plane concerns. But version 2 came out end of August, and it's still in its early phases. So what do we need to achieve this even on version 1.x? Enabling the admin GUI and API on the control plane nodes only was mandatory for us. Enabling developer portal on all nodes is required, but we wanted it to be served only by data plane nodes. And then we wanted to enable Prometheus metrics and health checks on all nodes, which, having disabled the admin API, we'll see is not trivial. We said we usually choose Cassandra for our deployments, but that doesn't mean it's the best solution for all the situations. Kong supports 2 DBs, Cassandra and Postgres, and since a few releases can also be deployed in DB-less mode. But the aim of this mode is slightly different. The absence of shared state between the nodes doesn't allow some plugin and enterprise feature to work properly. Our choice usually follows this simple rule of thumb. If you have the possibility to use a managed DB, for example, you are on AWS and you can use an Aurora cluster, go for it. The DB will be relatively small and low maintenance, so even a few small instances will be more than enough. If that's not the case, but you have some existing skills in the company about using one of the 2 options, choose that one. If even that is not the case, if Kong is handling production traffic, you will not want the database to go down often. So it's mandatory to have it in HA with a long mean time to failure. Therefore, the easiest solution will be Cassandra, as it's natively distributed, while Postgres will need some more care to achieve the same degree of resiliency. Lastly, if you can guarantee a short mean time to repair, also a single Postgres instance with a well-organized backup and restore strategy could be sufficient. Keep in mind that Kong will keep working for a while, even if the DB is down, and usually its size will be around the 100 of megabytes, totally manageable. As I was saying, in version 2.x, we have more deployment options among the other many changes. So we have classic mode, the same as version 1.x, in which all nodes communicate through the DB. So everything we'll speak about in this talk still holds. And hybrid mode, the control plane in which control plane nodes are the only communicating with the DB, and the data plane nodes are pulling the configs from the control plane directly. But it has its limitation. For example, some of the plugins are limited in their functionalities. See the out plugin, for example. So far, we have described the architecture and the DB selection. Now, we'll see some configuration tricks we needed in order to enable a few essential features without enabling the admin API, as we were saying before. Nowadays, observability and monitoring are mandatory requirements to have a production-grade system. Specifically, load balancers in front of the data plane needed an health check endpoint in order to route the traffic to working instances, And regarding monitoring at SIGHUP, we are focused on everything Kubernetes. So Prometheus is obviously our monitoring tool of choice. Therefore, we needed Prometheus metrics exposed by all nodes. If you want to do the TLS termination on the load balancer in front of Kong, you'll need an L7 load balancer. These usually require some kind of health check endpoints to be able to route traffic only to healthy instances. But Kong does not provide such an endpoint if you disable the admin APIs. So what we decided to do was to set up a /status route with the request termination plugin, returning a 200 status code. But we wanted it to be automated and reproducible, so we had to do it with Ansible. We try to always keep in mind security. Therefore, we wanted to enable RBAC and authentication on the admin APIs. This complicates everything because we will have needed to pass tokens and credentials in order to configure the route. So what we had to do was to start Kong with RBAC and out disabled on the first setup, configure the route and the plugin, as you can see in the picture on the side, and then restart Kong with them enabled. Regarding Prometheus metrics, in Kong, everything is a plugin, and Prometheus is not an exception. The problem is that by default, the plugin is exposed on the admin API port, which again, we have disabled. So we had to go with a third option proposed by the documentation, given that all the other were assuming the admin API were enabled and tried protecting them in various ways. To do so, we needed to add a custom server block listening on a different port and exposing the Prometheus metrics. Take care that metrics will start appearing on your Grafana dashboard only after some traffic has hit the node, so do not despair if you see them empty in the beginning. And then Samuele will speak about our DB of choice.
Thank you, Philippe. So here we are with our database choice for our Kong architecture, Cassandra. As already said, we choose this database to its distributed nature and resiliency. We needed a highly available database when on-premise without a lot of operational overhead. The problem was automating the Cassandra clusters installation and lifecycle, and sometimes in an air-gapped environment. Our starting point was an open source Ansible role from a company named League of Crafty Programmers. You can see the link here. This role has all the tasks you need to install the Cassandra cluster on all the main Linux distribution. After taking care of the lifecycle, we also needed a robust backup tool, and for this, we choose a tool named Medusa, originally from Spotify and now maintained by The Last Pickle. In addition to these roles, we also use some customization on the customer side to make them fully air-gapped. This means downloading all the packages of Cassandra and Medusa and modify the Ansible role to copy the files on the target server and use them to install instead of the classic yum apt repositories. 3 Cassandra nodes makes our reference architecture. This ensures a fault tolerance of one node. The authentication option we choose is password out. Our Cassandra cluster is used only by one Kong cluster at a time. We are not sharing a Cassandra cluster with more than one Kong cluster. Using Cassandra adds some more challenge on the Kong setting side, mainly because you need to tune the Cassandra consistency you want and how much timeouts to give on the queries. Our defaults are Cassandra consistency set to quorum and Cassandra timeout set at 15 seconds. The default of 5 seconds is not enough because it gives random errors when using Kong admin APIs. Remember also to assess the Cassandra replication factor on Kong configuration before running the first migration. This ensures that the Cassandra key space has the right replication set. If you forgot, there is no problem. Remember to change it with an alter query afterward. What if someone makes an error on Kong Manager? Deletes a fundamental role or some other core settings you need? Or perhaps a catastrophic event destroys all the nodes in your data center. It would help if you had a robust backup solution. For this, we choose the Medusa backup tool that can backup a full cluster on a remote NFS folder or a S3 compatible bucket. We run the backup as a cron tab, and we name it with the date plus hour and minutes. This ensures that each node will start the backup with the same name. The same name is needed to give Medusa all the necessary information to check if the backup is complete, how many nodes are missing, and so on. You can also list the backups, verify them, etc. And obviously restore them in a catastrophic scenario. For this, we run an Ansible playbook that runs the restore simultaneously on all the nodes of the cluster. You can use this approach on an existing Cassandra cluster or a new one created with the same infrastructure as code. The restore in place ensures that the correct data will be restored on the correct node. When everything is restored, we always do a Cassandra repair to fix eventually inconsistent data between the nodes. So now let's talk about CI/CD. We all know the tool deck made by RBAC. This tool is the infrastructure as code approach for Kong APIs. When we showed deck tool at big enterprise companies, they asked why the RBAC users were not working with deck. We started looking into the deck code and we did a small PR to add the compatibility for RBAC users. To use an RBAC token with deck, you will need to add the key skip workspace CRUD in the config for deck. An RBAC user is a bot user inside a workspace. It cannot manage other workspaces. This flag ensures that nothing related to the automatic creation of workspace and some other deck automation is triggered. Let's now talk about another nice tool that Kong provides, Portal. The next thing we automate is the developer portal management. We wanted to manage this tool in a GitOps way, and we do as we do in all our other projects. Portal will automate all the developer portals lifecycle management for you. It's an awesome tool for CI/CD purposes. How does it work? First of all, you need a definite folder hierarchy to work with Portal, and then you will need a file named cli.conf.yaml. In this file, you will put your admin API URL and your RBAC user token. This tool is already working with RBAC user tokens. You can then start doing all the things and more you usually do on the Kong manager. You can enable the portal, fetch all the files from it, change them on your local machine, and obviously deploy them. This tool is also handy when it comes to deleting the developer portal from a workspace. This is needed when you want to delete a workspace from Kong, because Kong will complain about it when there are some data left in their workspace, being them Kong resources or developer portals files. So as for now, we have seen two tools to manage different parts of Kong infrastructure as a code paradigm. But how do we combine them? With one big infrastructure as code folder. This is obviously a starting point. You can split all the projects in different repositories with different accesses if needed. But having all the resources in the same place makes life easier for the team in charge of managing your APIs. They can change the deck configuration and contextually change the Swagger OpenAPI definition of your APIs in the developer portal. All the secrets, RBAC user tokens, and so on can be managed on the CI/CD of choice without exposing them to the repository. For a reference, we set all our RBAC users as super admin on the workspace for simplicity, but you can put your fine-grained permission in place with some testing. We made a little repository with this example at the link below. Now let's go back to Philippe.
Thank you, Samuele. So let's see a last tip before talking about our beloved Kubernetes. One of the most useful plugins for us to satisfy all the requirements from our customer has been the serverless plugin. This plugin allows to write simple stateless functions written in Lua to be executed in any of the usual OpenResty phases of a request lifecycle. Plugins ordering in Kong is a bit of a painful point, as we usually cannot configure it custom on the plugin configuration, but only at build time. But at least here we are provided with two flavors, executing before or after all the other plugins. Here we can see a few examples of use cases in which this plugin has been useful for us in the past, but imagination is the limit. So far, we have covered classical deployments of Kong, but as I said, at SIGHUP, we love Kubernetes. That's our main focus. So what about Kong Enterprise and Kubernetes? We are provided with two confusingly named options to deploy Kong Enterprise in Kubernetes. Kong Enterprise on Kubernetes and Kong for Kubernetes Enterprise. The first option is Kong Enterprise on Kubernetes, which allows to run a classical full-fledged installation of Kong Enterprise on Kubernetes. This allows to handle Kong through the Kubernetes APIs, which might be useful depending on the cases, like scaling, rolling upgrades, and configuration. And the second allows to deploy Kong Enterprise in Kubernetes as an ingress controller. If you are not familiar with ingress controllers, these usually are L7 proxies deployed inside a Kubernetes cluster, implementing ingress resources, therefore routing based on host names and paths to services deployed in Kubernetes. Kong here is doing exactly this, plus a few things, like plugins, consumers, and users, always configured as Kubernetes resources through some convenient CRDs, custom resource definitions. Given the specific use case, it's going to be incompatible with few enterprise features like the developer portal, the brain, immunity. On the other hand, from version 2.1, it still allows to have Kong Manager in read-only mode and vitals via Prometheus or Influx. Here you can see a short list of the resources it provides to configure Kong via Kubernetes APIs. We have plugins that can be associated via annotations to ingresses or services. You can see an example here on the side. And we have Kong ingresses, which are a resource to extend the standard ingresses with Kong-specific functionalities. TCP ingresses to allow L4 routing on different ports, and Kong consumer to define consumers and credentials to access specific APIs as we are used to on Kong Enterprise. And so this is it. Thank you for joining us.
Thank you all.